Okay, here's another proof problem. Right here it says, if x is rational and y is irrational, then we are going to show that x plus y is irrational. How do we approach this? Remember, whenever you're trying to show a statement that has a not in it, then you can try to use contradiction, which is the following. We are going to assume this and that, but not this. That's the idea behind contradiction. The idea behind contrapositive is that we're trying to show if this is not true, then the original condition is also not true. But it has two parts. I think it's slightly harder to do the contrapositive. So right here, PF, I will just mention that by contradiction. And then I will just say, assume that we have this and that already, but we don't have that. So assume x plus y is rational. Okay, what can we do when we have a rational number? Well, the definition of a rational number is that it's a ratio of, let's say, a over b, and a and b are integers. So we can say, then write x plus y being equal to a over b. And right here, you should also write some stuff down, such as a and b are integers, but b is not equal to 0, because otherwise you are dividing by 0, of course. And remember, whenever you write a fraction, you can assume that a and b have been reduced, right? The smallest possible for you to make this work. So I will further assume that and assume. And I can say the greatest common divisor of a and b is just equal to 1. The idea is that if you have, let's say, 2 over 6, don't bother to write that. Write it as 1 over 3. That's the idea. So they don't have any common factor. Now, so far so good, but how do we continue? Go back to here. Remember, you always go back to the conditions. If you don't use your conditions, then something's wrong. So we have this. I will just say since x is rational, then write x being equal to, let's say, m over n, and same thing. M and n are integers, n is not 0, and then greatest common divisor of m and n is just equal to 1. Okay, so far so good. Now check this out. I'm going to put this back here, so we will have, then we have m over n plus y, and then that is just equal to a over b. Now I'm just going to move this to the other side. So this implies y is equal to a over b minus m over n. What can we do right here? Well, let's just combine the fractions. So we see that y is equal to, get the common denominator is just bn. Right here, multiply n and n, so that's an. And the minus multiply b and b, so it's bm. So y is equal to this. Now, what's wrong with that though? Here's the deal. A, b, m, and n, they are all integers. And integers are closed under multiplication and addition and subtraction, not division though. But what we are talking about here is that, notice that y, this part, this is an integer. Likewise, this is also an integer. And now that's a problem, because y is a ratio of 2 integers, and of course m and n, they are not equal to 0. So when you multiply them, it's not equal to 0. This contradicts with what we have right here. I'll just mention that contradicts with y being irrational. And that says we're done, because we have the contradiction right here. And for a contradiction proof, I usually put down an arrow going right and then an arrow going to the left. That's it.